Hello YouTube, this is UMelzo3. It's the first day of 2022, so hopefully your year goes smoothly, and if you're watching this in 2028, hopefully the rest of your 2028 goes well. In the previous video, we talked about concurrent hash maps, and we basically defined a fourth dictionary that we can use. We're talking about collections of key value pairs, right, where we basically map a key onto a value, and we can have multiple key value pairs in the same dictionary. And we said the keys in a dictionary have to be unique, but the values in a dictionary don't have to be unique. So now we're familiar with four types of dictionaries, and I wanted to go over the capabilities of them as far as iterators go, right? We've been talking for 15 or 20 lessons about iterators, right? And also enumerations and list iterators. So a dictionary is a data structure containing key value pairs, and the keys in a dictionary have to be unique, but not the values, right? So we talked about first a hash map, and we can perform an iterator on the key set or an iterator on the values, right? So if you had a particular dictionary called X, you could call x.keyset.iterator, and that would have the capability of iterating through the keys in the dictionary. You could also say x.values.iterator, and that would iterate through the values in the dictionary. You also have those capabilities with a hash table, which is another type of dictionary that we talked about, but we said with a hash table, you can also do an enumeration on the hash table itself, and that would basically have the effect of enumerating on the values, right? But we said that iterators are better than enumerations, so there's no real critical need to understand enumerations. With a linked hash map, that's just a subset, that's just a subclass of hash map. So you'll also have an iterator on the key set or an iterator on the values. But one of the things we didn't say in the previous video is that a concurrent hash map has no iterators, okay? So you can't iterate through the keys of a concurrent hash map. You can't iterate through the values of a concurrent hash map. But remember, in order to use concurrent hash maps, you have to remember to import java.util.concurrent hash map, right? And I've also imported some other classes that we can use. So the hash map, the hash table, the linked hash map, so we can compare and contrast these four different types of dictionaries. And we're also going to be using iterators, vectors, and list iterators in this video. So what we're going to do, we can understand that all four of these dictionaries, all four of these types of dictionaries support a put method, which returns the previous value for that key, or null if none had existed, right? So remember that some of these methods don't just perform a task. You don't just add a key value pair to the dictionary, but that method also returns something. And we looked in the API and we saw that the put method returns the previous value for the key if you were replacing that key with a new value, right? Or null if that key value pair had not existed. If that key was not already in the dictionary, then it would return null. And the get method returns the value associated with the input key. The put all method, we saw an example of that in the previous video, but that's a void method that adds the key value pairs from the input dictionary into the dictionary on which the method is called, right? And we saw an example of that in the previous video. And then the size method returns the number of key value pairs that are currently in the dictionary. The isEmpty method returns true if there are zero key value pairs, false if there's at least one. Remember, clear is a void method that removes all key value pairs. Contains key is a Boolean method where obviously you feed in a key and it returns true if that key is in the dictionary. Contains value is a Boolean method that returns true if that value is in the dictionary that you feed into the method. And then contains is the same thing as contains value. It's called a legacy method. It's an older method, but you can either just write contains or contains value. And then there's a replace method. So what if there's already a key value pair in the dictionary, but you want to reassign a value, right? You want to basically pick a different value for a particular key to have, okay? So you would use the replace method. So replace of A, B. So that returns the old value that B is replacing. What was the old value that A was attached to? And that's what will be returned by the replace of A, B method. But if you say replace of A, B, C, right? If you feed in three inputs, then basically we said that that has the effect of assigning the value C to the key A if and only if the original value associated with key A had been B. So hopefully that makes sense to you, but this method would return true if the value was replaced and false otherwise, okay? And then there's also a remove method, which removes the key value pair if you specify a key, and that would return true if the key value pair was removed and false otherwise. Like if you tried removing a key that wasn't in the dictionary, it would return false. And then there's also a toString method. So we saw an example in the previous video about how we could have a clean string representation of a dictionary. but I basically declare these 4 types of dictionaries. So hash map A, hash table B, linked hash map C, concurrent hash map D. Okay, and we're going to have the keys be strings and the values be integers, right? And then we initialize those 4 dictionaries on these 4 lines. And then we're going to say a.put of tomato 4, a.put of pizza 99, a.put of potato 64. And then what we're going to do is we're going to say system.out.println of a.replace of potato, a.get of potato plus 2. So what this does is it reassigns the value associated with the key potato to whatever the original value was for that key potato plus 2. So it would be 64 plus 2, which is 66. So that's going to be the new integer associated with the key potato. And then we could say a.put of apple 83, a.put of avocado 8. And then we have another, and so that's for a hash map. And then for this hash table B, we could say b.put of apple 81, b.put of orange 72. And then we could say a.put all of B. And we basically said that that would basically try to insert all the key value pairs from B into A. So then what we do is we say iterator of type string, iterate keys of A, that's just what I'm deciding to call the iterator, equals a.keyset.iterator, and then string current key in S. So it's just going to declare a string and then declare an integer. And then we're going to say for S equals 0, iterate keys of A.hasNext and true, right? So this and true doesn't really make that much of a difference. S++, current key equals iterate keys of A.next. So it basically fetches the next key in the dictionary. And then system.out.print of key equals, and then whatever the key is, and then system.out.println of value equals a.get of current key. So that would basically retrieve the value that's associated with that key. So anyway, let's go ahead and compare and contrast the code with the output. So I would run the dictionaries method. And so we can go ahead and get a sense of what's going on here, right? So we basically see what's going on here. So we have the 64, because we said that the replace method, if you have replace of A, B, that returns the old value that was being replaced. So now we're going to lose the 64, and the new value associated with potato is going to be 66, right? And then the B, the hash table B, also contributed an apple and an orange. And that's why you see those key value pairs in A now, in the hash map A, because we said a.put all of B. But then we can say, you know, key equals and then value equals, right? And then that just has the effect of using an iterator to print the key value relationships in the A hash map, in the hash map A. And then system.out.println of S equals A.size. So is the final value of S, after we keep incrementing it by 1, equal to the size of the hash map? Well, yes, it is. So it would be true. And then we could have a clean string representation of D, right? So we could say for C and D, so C is an empty linked hash map and D is an empty concurrent hash map. So you could say C.put of dog 90, C.put of cat 61, C.put of horse 66, and then D.put of horse 62. So here we have sort of a coincident key, but 2 different values. So the question is, if we do D.put all of C, what we saw in the previous video is basically the value would be overwritten. So now the D in the D concurrent hash map, the value for horse would no longer be 62, it's 66. And we get this clean string representation where it says horse equals 66, cat equals 61, dog equals 90. But you don't want to think of it as an equality. Basically, this equals sign is just sort of connecting each key to the corresponding value. So hopefully that's clear to you, and that's our review of the 4 types of dictionaries. I also wanted to quickly review list iterators in this video because we talked about it in a previous video, but we didn't do so much justice to the topic. So remember, list iterators are only accessible to stacks and vectors. And the reason is because it's a method that belongs to stacks, but vector is a subclass of stack. And when we were talking about inheritance, we said that any subclass will be able to access methods from the superclass. So you could say vector of type integer, my vector, equals new vector of type integer. And then we could say my vector.add of 26, my vector.add of 32, my vector.add of 21, my vector.add of 05. So remember, if you specify 2 arguments, then it inserts into index position 0 the value 5, and it would shift all subsequent elements 1 index position to the right. That's something that we talked about in a previous video, right? But we could go ahead and compile it, and we could go ahead and see what the output is going to be here. So I'm just going to try to pull this up. So basically what happens here is we added 26, 32, 21, but then we're going to stick the 5 in front. And then we're going to say list iterator of type integer q equals my vector dot list iterator. This is how you go ahead and create a list iterator. And you have to just remember to import java.util.list iterator at the top of your class if you want to use a list iterator. But we said one of the benefits of using a list iterator over traditional iterators is that a list iterator can also move backwards rather than forwards. And a list iterator can also add or remove elements from the underlying data structure. That's a cool feature that's available to list iterators that's not available to traditional iterators. So right now, Q is looking at index position 0 within the vector. And so what we're going to do is we're going to say Q.add of 542, Q.add of 999. So this element is added to the beginning of the vector. These elements are going to come into the beginning of the vector because when we created the list iterator and when we called .add on it, basically it sticks those elements into wherever the cursor position of the list iterator currently is. And when we create the list iterator for the first time, the cursor is going to be at index position 0. So if we say system.out.println of my vector, and then we would basically get 542, 999, 582, 32, 21, because these elements were inserted at the beginning. And then we basically jammed the 5 into index position 0, right? The original position 0. And then we have the 82, the 32, and the 21, because we replaced, I guess, the 26 with 82, and then we have the 32 and 21. And then we could say, well, Q.has next, Q.next. So we're just going to basically keep moving to the end of the vector. Okay, so you don't have to do anything with Q.next. You can just call it, and it has the effect of moving the cursor position to the end of the vector. And then you could say, well, Q.has previous, system.out.println of Q.previous, and then Q.remove. So basically, it's going to basically traverse the vector in reverse order. So it'd be 21 and then 32 and then 82 and then 5 and then 999 and then 542, because it's moving through the vector in the opposite direction. And that's the point of a list iterator, is that it has that functionality available to it. And then you can also remove elements from the underlying data structure. That is something that you can do with a traditional iterator, but of course you can also do it with this list iterator, which is what we're using now. And then if you say system.out.println of my vector.is empty, it would go ahead and return true, because if you're just going to keep continuously removing the elements from the underlying data structure, then by the time you're done with that process, the vector is not going to have any more elements in it. So hopefully that's clear to you, and that gives you a slightly better sense of how list iterators work. What we're going to do in this video is talk about pass by value. So in Java, what we have to understand is that Java passes information by value. So that means that it makes a copy of a variable and uses that copy within the context of the static method. Okay, so what we're going to do, we're going to see some unexpected behavior here. So what we're going to do, I'm just going to scroll down, and we're going to scroll down to a main method. So we're going to say in r equals 52. So remember, this declares an int. And then this goes ahead and initializes the int. It provides an initial value to it. And we say system.out.println of r. So hopefully we'll expect 52 to be the first thing printed to the console if we run the main method. And so it says 52. Okay, and then it says let's add 1. And then we're going to say pass by value dot add 1 of r. So you could have just said add 1 of r, right? With static methods, if you're using a static method that belongs to the same class as the code that's calling the static method, you don't have to call the class name, but you can. But you could have just said add 1 of r. But since this add 1 method right here belongs to the pass by value class, it's a little more formal to say pass by value dot add 1 of r. Okay, so basically what the add 1 method does is it accepts a t and increments it by 1. So presumably if you pass in 52, it would basically say, okay, t plus plus, so then t would become 53. But then if we say system.out.println of r, it still says 52, and that's probably not what you were expecting. And the reason is because the 52 is passed in as a copy to the add 1 method. So when you call add 1 here, basically the 52 is incremented to 53, but then that information is lost because we're basically just dealing with a copy of the variable. We're just using the value of the variable rather than the variable itself. So we're passing by value rather than by reference, and this leads to some unexpected behavior because it seems like the static method will be capable of incrementing a variable by 1, and then we should have had 53 after calling the add 1 method. But here it just says 52 on either side. That's because Java passes information by value. There are three solutions to deal with that. There are three different things that you can do if you actually want to increment 52 to 53. So let's talk about the three approaches that we could do to prevent an issue like this from happening. The first solution you could do is you could use an instance variable and update it as it belongs to a particular object. So we're working in a class called pass-by-value now. This is the name of a class. And what we could do is we could go ahead and attach an instance variable to the class. So we have private int my number, right? This is an instance variable that belongs to the pass-by-value class, okay? And so what we can do, so there are three solutions that we can talk about for getting over this hurdle where we expect it to increment 52 to 53, but it didn't actually work. And the first solution is to use a private instance variable and then an instance method rather than a static method. So the first solution is to scroll all the way down here, and we're going to say public static void solution1 of pass-by-value x. So it's going to accept an instance of the pass-by-value class. It's going to accept a pass-by-value object, and then it's going to increment the instance variable for that particular instance of the pass-by-value class by 1. So if you feed in an x, you're going to say x.myNumber plus equals 1. Remember, this was the name of the instance variable that we were just looking at. You could say x.myNumber plus equals 1, and it's still a static method, it's still void, but now we're passing in an instance of the class. And then we're going to use an instance variable. We're going to increment an instance variable rather than just some local static variable, because that didn't seem to work very well for us. So now what we're going to do is we're going to try this again. So what we're going to do is we're going to uncomment this little section here. So we're going to say pass-by-value p equals new pass-by-value of 52, system.out.println of p.myNumber, right? So we can print the value of that instance variable, and it would presumably be 52, right? And then we could say system.out.println of let's add 1, and then solution1 of p, right? This is a static method. You could have also said pass-by-value dot solution1 of p. That would be more formal, but you don't have to say the class name if you're in the same class as the method that you're calling. And then you could say system.out.println of p.myNumber. So hopefully by using this approach, by passing in an instance of the pass-by-value class and then incrementing the instance variable, hopefully this will work out a little bit better for us. So now if we go ahead and try to run the main method, now you can see, just look at these three lines here. So now it says 52, let's add 1, and then we get the 53 that we're looking for. So that's one approach that you have to deal with this pass-by-value hurdle where it seemed like the 52 didn't get incremented by using a simple static method. The solution is to pass in an instance of the class and increment the instance variable that belongs to that particular instance. And that's what we did in this code right here. The second solution is to use a method that returns an integer. So you could have said public static int solution2 of int a, and then you could say return a plus 1. And so now let's see that in action. So we're going to say int q equals 52, system.out.println of q, and then system.out.println of let's add 1. Q equals solution2 of q, system.out.println of q. So here, this method now returns a new result for q. So then q goes from 52 to 53. So this is just another technique, is instead of using a void method, you could return a new value. And then this works a lot better than this pass-by-value thing that we were looking at originally, where the 52 didn't seem to increment, but you would just say return a plus 1. So then if we go ahead and run it, and I need to go ahead and comment that out. So we go ahead and run it, and then we go ahead and compile it, and then run it. And then we get the same thing. So then we get the working behavior again. So it says 52, and then let's add 1, and then we get 53. So this is another approach that you have, is instead of just using a void method, you could return a new value for the particular integer, right? And so then you would just reassign it to 1 plus whatever you passed in. So that's another approach, as you use a return type rather than a void type. The last solution that you have is to use a one-dimensional array with one element in it. So what we're going to do is we're going to say int w, it's going to be an array with one integer in it. So we're going to say int w and then square brackets equals and then curly braces with just 52 in it. So it's just a one element array. And then we're going to say system.out.println of w of 0. So presumably this will be 52. And then we can say let's add 1. And then we're going to say pass-by-value.solution3 of w. So what does this solution3 method do? Well, it accepts a one-dimensional array of ints, and then it basically seems to increment the first element in the array by 1. So we say x of 0 plus equals 1. It just increments the first element in the array by 1. So then if we say pass by value dot solution 3 of w and then system.out.println of w of 0, hopefully that 52 would be incremented to 53. So then if we go ahead and compile it, again, we see that the behavior works as intended. So that's how pass by value works. And hopefully that gives you a sense of the three approaches that you have to passing by reference instead. From you, Mills03, thanks for watching, and please subscribe.